Okay, in this video we're going to study work and friction by first dragging a gym bag, across a rough gym floor. We're dragging with a force of 100 newtons applied at a 30-degree angle to the floor. And we're looking to do a couple things. We want to determine the work required to drag this bag 10 meters across the floor in the x direction. And we'd like to find the coefficient of kinetic friction. Kinetic definitely because it's already moving. So we're going to make use of the fact that the velocity here we're going to assume is constant. We're just dragging it across the floor, not accelerating it. So to find the work equals force times displacement, but the force and the displacement are both vectors. They're represented with arrows, and those arrows have to be in the same direction. The problem we have is the 100 Newton force is not in the direction that the displacement is. So we're going to break that into components. We're going to break it into the cosine component, which is in the x direction. That would be 100 cos 30, or that's a value of 86.6 newtons. And then in the y direction, we have 100 times the sine of 30, and that would be, of course, 50 newtons. So completing now the work required to drag this bag in this manner, 10 meters would be 86.6 newtons times the displacement of 10 meters, or 866 newton meters, which is 866 joules of work. To do the second part of the problem, to find the coefficient of kinetic friction, we're going to be using Newton's second law, which is F net equals ma. But keep in mind with this law that once again the force is a vector which is causing the mass to accelerate in the same direction as the force. Note that the arrows agree in the same direction, x direction. FFES, that's our fantasy football every Sunday, or actually it's frame. In this case, it's the positive x direction. That's the direction the bag is being dragged. The second F is for force diagram, which we'll be doing on the bag. Only then will we fill in the equation, and then finally we'll solve the problem. So once again, we have our frame, which is the positive x direction, and now we're doing a force diagram on the bag. So we have the weight, which is 400 newtons down. We have the 100 Newton force being applied at the angle. We have the friction force, which opposes motion. Now, because our motion is in the positive x direction, the friction force is in the negative x direction. And we have the normal force, which we're initially tempted to think might be 400. But then we realize the 100 Newton force is not in any of our frames, so it has to be broken into components. When we do this, and if we isolate now and the forces in the y direction, we have the normal force going up and the 50 Newton force going up, the component force. We have the 400 going down. So in the y direction, since we're not accelerating, all those forces have to balance out. So the normal force plus the 50 will have to equal the 400, and that gives us a normal force of 350 newtons going up. At this point, we're ready to put our forces in the equation and solve the problem. Our frame is positive x direction, so 86.6 is positive. The friction force, which is the normal force times the coefficient, is negative. That's going to equal to the mass times the acceleration, but we already said the acceleration is 0. That gives us the coefficient of friction equal to 86.6 newtons over 350 newtons, and that will give us a unitless number, which we want, a coefficient of friction of 0.247.